Evaluation of the Census transform as an improvement in the detection of pulmonary fibrosis due to long COVID. Good afternoon, everyone. Today I will be presenting our research, Evaluation of the Census transform as an improvement in the detection of pulmonary fibrosis due to long COVID. This study explores the application of a specialized image transformation technique in enhancing the accuracy of convolutional neural networks for the classification of thoracic CT scans. Our motivation lies in the increasing need for rapid, reliable, and automated methods to detect post-COVID-19 complications, especially those involving long-term damage such as pulmonary fibrosis. Our educational institution. Our research was conducted at the Engineering Division of the Irapuato Salamanca campus, also known as Census, which is part of the University of Guanajuato, located in the state of Guanajuato, Mexico. Census is a multidisciplinary division known for fostering innovation in areas such as intelligent systems, biomedical technologies, and applied computer science. Our team consists of undergraduate researchers, academic staff, and medical collaborators, all working together to develop data-driven solutions for health diagnostics. Understanding pulmonary fibrosis. Pulmonary fibrosis is a chronic, progressive, and irreversible lung disease. It causes the normal lung tissue to become scarred and stiff, reducing the lung's ability to expand and contract efficiently. This results in restricted airflow and reduced oxygen exchange, often leading to symptoms such as shortness of breath, dry cough, fatigue, and reduced exercise tolerance. While idiopathic cases are common, pulmonary fibrosis can also be triggered by environmental exposure to pollutants, certain medications, autoimmune diseases, or infections such as COVID-19. As a consequence of the COVID-19 pandemic, a growing number of patients are exhibiting signs of long-term lung damage, which often manifests as fibrotic tissue development. Detecting pulmonary fibrosis early is essential for initiating treatment plans and slowing disease progression. Computed tomography, CT, scans are the preferred imaging method due to their ability to provide high-resolution visualization of lung structures, helping physicians identify fibrotic patterns like ground glass opacities and honeycombing. Research objective. The main objective of this research is to evaluate the effectiveness of the Census transform as a preprocessing technique applied to thoracic CT images. This transform is intended to highlight key features such as texture and structural variation, particularly useful for identifying fibrotic changes. By applying this transform prior to classification, we aim to enhance the input quality for a pre-trained convolutional neural network, CNN, improving its ability to detect pulmonary fibrosis linked to long COVID. This approach aligns with the need for low-cost, scalable, and AI-assisted tools in medical imaging. Core concepts: Census transform and CNN. The Census transform is a non-parametric descriptor that evaluates local intensity variations in an image. For each pixel, it compares its intensity with that of its neighbors, generating a binary representation that encodes local structure. This technique is particularly robust to illumination changes and noise, making it ideal for medical imaging, where subtle texture differences are diagnostically relevant. In this context, the Census transform allows us to accentuate fibrotic patterns in CT scans, such as reticulation, septal thickening, and honeycomb-like structures. We then use a convolutional neural network, or CNN, which is a deep learning architecture specialized in analyzing visual data. CNNs automatically learn spatial hierarchies of features through convolutional filters, pooling layers, and fully connected layers. To optimize our training, we adopt transfer learning, where we use the pre-trained VGG16 architecture. VGG16 is well known for its performance on the ImageNet dataset and provides a solid foundation for medical classification tasks, even with limited data. Methodology, data and approach. The dataset consisted of 57 CT images, collected in collaboration with the General Hospital in Leon, Guanajuato. These were categorized into two classes: 39 images from patients with pulmonary fibrosis due to long COVID and 18 images from patients without any signs of fibrosis. Despite the small size, the dataset allowed us to experiment with targeted image processing and transfer learning techniques. Our workflow included 1. Image preprocessing. All images were resized to match the input dimensions of VGG16. We normalized the pixel intensities and ensured consistent formatting. In one experimental branch, we applied the Census transform to all images, enhancing local structure information critical for fibrosis identification. 2. Model selection. We used the VGG16 CNN, fine-tuned using our dataset. The top layers were replaced with fully connected layers appropriate for binary classification. 3. Training strategy. We trained two separate models, one using raw CT images, and one using Census transformed images. We used an 80-20 split for training and validation, along with data augmentation techniques to mitigate overfitting. 4. Evaluation metrics. To assess performance, we calculated accuracy and precision, focusing on how well the models correctly classified fibrotic versus non-fibrotic cases. Results. Performance evaluation. Our results demonstrate a measurable improvement when using the Census transform. Here are the key metrics. Without Census transform, accuracy, 87%. Precision, 87%. With Census transform, accuracy, 91%. Precision, 91%. The transform's ability to highlight relevant textures likely allowed the CNN to extract more meaningful features from each scan. Visual analysis of the activation maps from the CNN also confirmed that the Census transform enhanced regions corresponding to known fibrotic structures. This suggests that the Census transform may act as a valuable feature enhancement tool, especially in medical contexts where image texture is critical. Discussion. Interpreting results. These results confirm our hypothesis. The Census transform improves CNN-based classification of pulmonary fibrosis. By focusing on local image structures, the transform supports better generalization and feature discrimination, helping the network detect subtle fibrotic patterns while precision and accuracy improve. Further testing is necessary to verify how this approach performs on larger, more diverse datasets. The small size of our current dataset introduces limitations in terms of statistical significance and model robustness. Additionally, CT scans can vary depending on imaging protocols, patient position, and machine type, all of which must be considered in future studies. Nevertheless, this study presents a promising and lightweight enhancement method that could integrate easily into AI-assisted radiology workflows. Conclusion. To conclude, our study shows that applying the Census transform as a preprocessing step can significantly improve the detection of pulmonary fibrosis in CT images using deep learning. This improvement is particularly valuable in the context of long COVID, where subtle lung damage may go undetected in early stages. By enhancing structural textures and feeding more informative data to a CNN, we observed clear gains in classification performance. This supports the idea that intelligent image preprocessing can be just as important as model architecture in medical AI applications. Moving forward, we plan to expand our dataset through partnerships with more hospitals, experiment with other texture-enhancing transforms, and evaluate our pipeline using other deep learning models and segmentation-based approaches. Acknowledgements. The authors gratefully acknowledge the General Hospital in Leon, Guanajuato, who generously provided the CT scan data that made this research possible. We also thank our colleagues at Census for their continued support and mentorship throughout this project. Thank you very much for your attention. We appreciate the opportunity to present our research at this prestigious IOM Society International Conference. If you have any questions, we would be happy to answer them.